Hey students, I'm out today, as you know, and we're going to take notes for sections 2.5 and 2.6, and we're going to start with section 2.5 right now, addition equations, and I want you to set this up in your notes, just like we've been doing each section since the beginning of the year. So 2.5 addition equations, and today's objective is learn to solve whole number addition equations. Now would be a good time to pause the video and let students do that. Okay, now that you've got your objective written and your notes set up, I would like you to do the warm-up questions for the day on the whiteboards. Now, again, please pause the video so that students can work on the warm-up questions. Okay, now that you're done with the warm-up questions, let's go over the answers. Number 1 should have been yes. Number 2 should have been no. Number 3 should have been yes. And number 4 should have been yes. Okay, now let's do the problem of the day. Please pause the video so the students can read through this and try and solve this and put their answer on the whiteboard as well. Okay, students, let's take a look at the problem of the day and see how many of you got it correct. 53 meters was the correct answer. Okay, now in your notes, let's put a vocabulary section with just the vocabulary word, inverse operations. You do not need to write down the definition, which we will go over in a few slides, but I want you to be able to reference this. We've talked about this some. We talked about inverse operations already this year when we did PEMDASLR. As multiplication and division are inverse operations and they undo each other. They're equal in power to each other. So in the same step, you can multiply and divide doing math problems because they're inverse operations. They're equal in power. Same with addition and subtraction. You can do all the addition and subtraction in a math problem at the same time because they are inverse operations, and inverse and subtraction are equally powerful to each other. Okay, so let's look at a problem. The equation h plus 14 equals 82 can be represented as a balanced scale, where h plus 14 is equal to 82 on the scale. So to find the value of h, you need to put h by itself on one side and balance the rest of the scale. So if it's h plus 14 equals 82, how do we get h by itself? Well, what is the inverse operation of addition? Because we add 14, we need to inverse operate 14. So we're going to need to subtract 14 from h plus 14. And then we need to do that same thing to the other side of the scale, the other side of the equation, the other side of the equal sign. So if we subtract 14 from h, then we also need to subtract 14 from 82. 82 minus 14 is 68, and then we know that h equals 68. So if we take away from both sides, then we've done the same thing to both sides, then both sides are still equal. More written as an algebraic expression, it looks like h plus 14 equals 82. So if we subtract 14 from the left side of the equal sign, and then we need to subtract 14 from the right side of the equal sign. And as long as we do the exact same things to both sides of the equation, both sides of the equation will still be equal. So as long as we subtract 14 from both, h equals 68. This whole section is on addition, and we're going to do a few examples, but we're probably not going to do all the ones in the PowerPoint. But I will give you access to the PowerPoint in Google Classroom in case you want to reference it for your homework. Inverse operations undo each other. Addition and subtraction are inverse operations. If an equation contains addition, you solve it by subtracting from both sides to undo the addition. In sections 2.7 and 2.8, we'll see the same things with multiplication and division. Okay, so solve the equation and check your answer. We're given x plus 87 equals 152. Well, we have to do the same thing to both sides of the equation to make sure it stays equal. So how do we get rid of an added 87, we need to subtract 87. Well, we can't just subtract the 87 from the left side, then otherwise our equation will not be equal. So we need to subtract 87 from both sides. So we subtract 87 from both sides. 152 minus 87 is 65. X equals 65. And you can check that answer by plugging 65 back into the original equation and then testing to see if that equals, and if you're correct, then not only have you solved the problem, but you've double checked your work to make sure you're correct. Not a bad idea, especially on a test or a quiz. Okay, I'm going to pause the video right now so the substitute can have you solve this one on your own to test to see if you're understanding it. Okay, I'm going to read it to you and then pause it. 72 equals 18 plus y. Okay, that's a positive 18 being added to y. So how can we get y by itself on one side of the equation while still leaving both sides of the equation equal to each other? I'm going to go ahead, pause the video now. Okay, hopefully you've all had time to solve this, and hopefully you were all correct. So pay attention. If you got this wrong, you're going to want to know why you got it wrong. So pay attention to the correct answer. Okay, so we have our equation, and we want to subtract 18 away from both sides. So y ends up on that right-hand side by itself. Then we know exactly what y is equal to in this equation. So if we subtract 18 from both sides, then we're left with 72 minus 18 equals 54. 18 minus 18 is 0, so 0 plus y is y. So 54 equals y. Then, if you'd like, you can check your answer. Plug the answer you got back into the original equation and see if those are equal. If those are equal, your answer was correct. Again, not a bad idea to do during tests and quizzes to make sure you're correct. Okay, let's do one more, and then I'll give you the end of PowerPoint quiz, and you can check your understanding there, and then the substitute can give you the assignment for this section, let you work on the homework for this section, and then give you a break about halfway through the period, and then you can do section 2.6 and the homework for 2.6. Okay, last question to try on your own. U plus 43 equals 78. How can you solve for U? Let's go ahead and pause the video now, give the students a chance to work this problem out. Okay, you should have had time to solve the problem. Now let's check our answers. Okay, we were given U plus 43 equals 78. Let's look at what we do there. Okay, we need to undo the 43 being added to the U on the left-hand side of the equation. So how do we undo addition? We do subtraction. We want to subtract the same amount, so we should have subtracted 43 from both sides to make sure the equation stays equal on both sides. So we should end up with U equaling 35. Pat yourself on the back if you got that correct. You can always remember, check your answer, get a solution, plug it back into the original equation, and see if you're still correct. Okay, let's take the quiz. Okay, let's wait a second before we take the quiz and do a word problem. Johnstown, Cooperstown, and Springfield are located in that order in a straight line along a highway. It is 12 miles from Johnstown to Cooperstown and 95 miles from Johnstown to Springfield. Find the distance D between Cooperstown and Springfield. Well, we know the two distances. If we start in Johnstown and drive to Cooperstown, it's 12 miles. And then if we start in Johnstown again and then drive all the way to Springfield, it's 95 miles. So what's that difference between Cooperstown and Springfield? Well, let's set it up so we can understand it first. So the distance between Johnstown and Springfield is the distance between Johnstown and Cooperstown plus the distance between Cooperstown and Springfield. Okay, now what have they given us for this problem? Well, we know the distance between Johnstown and Springfield is 95, and we know the distance between Johnstown and Cooperstown is 12, And we don't know the distance between Cooperstown and Springfield. And so that's going to be our D. D for distance. And we're in algebra, so we use variables to represent the numbers we don't know. And that's going to be D. So there's our equation. 95 miles is that long distance between the two towns. And then 12 miles is that shorter distance between the first two. And then so how much distance is there left between Cooperstown and Springfield? Well, you should know how to do this now. Okay, we have a positive 12 being added to D. Okay, so how do we undo addition? Well, we do subtraction. So what do we subtract to get D by itself? Well, we're going to subtract 12 from both sides to make sure both sides of the equation stay equal, and we should find out shortly that the distance between Cooperstown and Springfield is 83 miles. Remember, make sure you're putting units on your values if there are units all the time. Math, science, any class, you're always putting units if there are units. Okay. Let's now. Okay, here is your quiz for section 2.5. I'm going to ask the substitute to go ahead and pause the video right now to give you a chance to do these problems. And when we return, I'll go ahead and go over the answers briefly. Okay, hopefully you've had enough time to go over each of these on your own, and hopefully you're all correct. So let's pay attention to what we were correct about and what we aren't correct about, and we're going to try and learn from our mistakes on this quiz. Okay, number 1, was x plus 15 equals 72? Well, how do we undo addition? We do subtraction, and we want x by itself, so we need to subtract 15 from both sides, and you should have got x equals 57. Okay. Then we have 81 equals x plus 24, and how do we undo addition? We do subtraction to undo addition, so we subtract 24 from both sides, and you should have got x equal to 57. Number 3, x plus 22 equals 67. Of course, you should have subtracted 22 from both sides, and x equals 45. 93 equals x plus 14. How do we get x by itself? We need to subtract 14 from both sides, and x equals 79. Now, we have a word problem and units, so you should have a solution with units. So Caitlin is 2 inches taller than Reba. Reba is 54 inches tall, so how tall is Caitlin? Now, you could sketch this out if you need to, but this is a little, this one's kind of simple. Often I'll ask you to sketch out the word problems just to make sure you understand them, and if you want, you can scratch this one out. But if Caitlin is 2 inches taller than Reba, and Reba is 54 inches tall, how tall is Caitlin? Well, then, of course, Caitlin is 56 inches tall. You need those units. Okay, now the substitute should give you your homework assignment for 2.5, give you some time to work on that, give you a restroom break about halfway through the class period when the other classes are not taking breaks, and then do section 2.6 with the remaining half hour of 45 minutes. Now, students, please work productively while you're in class. I want you to attempt both of these assignments before I see you tomorrow in science. Then if you have questions over these assignments, you can ask them in science, and I'll help you before the math homework is due, as long as you come tomorrow with them both finished and questions to ask. Thank you.